I'd like to talk about multiplying polynomials. In this particular video, I have trinomials and binomials being multiplied, and then I have binomials being multiplied by binomials. The one thing you need to remember that you need to add exponents of like bases when multiplying. And actually, it doesn't have to be like bases. Similar bases, not necessarily like. Similar is the better word. Because you can multiply x squared times x. Those aren't like bases. Well, they're both x, but they're not like terms. You can still multiply x squared times x. You get x, and then add your exponents. 2 plus 1 is 3. So remember, I think what I was intending to say, or I was thinking about when I wrote like, is you can't multiply x to the second times y to the third and get xy to the fifth. That would just be x to the second, y to the third. You don't change the exponents because these two bases aren't like or similar to one another. It has to be the same letter in order to add the exponents. Okay, so what do I do when I'm multiplying a binomial times a trinomial? Remember, when you learn this, and if you didn't learn it before, then you'll be learning it today, you're going to distribute. Now, there's a couple different ways you could write this. I like to write it this way. I'll show you. I like to draw arrows. I'm going to first distribute 6. I always say it looks like a rainbow. I'm going to distribute my 6 to each of those first. So 6 times 4a squared would be 24a squared. 6 times a would be positive 6a. 6 times negative 3 would be negative 18. And then I'm going to distribute my negative 2a to each of these. Negative 2a times 4a squared, negative 2a times a, and negative 2a times 3. So when I do that, I do negative 2a times 4a squared would be negative 8a. Add the exponents. 1 plus 2 is 3. Negative 2a times a. Negative 2 times positive 1 is negative 2. A times a. 1 plus 1 is a squared. Negative 2a times negative 3 is positive 6a. Now, when I'm putting my answer down, I want to make sure to put my answer in descending order, which means to put the largest exponent first. So as I look at this, my largest exponent is to the third power. My degree is 3. And I would put that first. I don't have any other a to the thirds, so I have negative 8, a to the third, and that's gone. Now I would look for to the second power next. I have 24a to the second power minus 2a to the second power, so that would be 22a to the second power when I combine. Remember, when you're adding and subtracting, you do not change exponents. These are like terms. I just put them together. 24 and negative 2 give me positive 22. So those are gone. Positive 6a and positive 6a. 6a plus 6a is 12a. Positive 12a. And then my only term left is a constant. That's negative 18, and there's nothing to combine with that. And this would be my answer to that problem. The next one, a lot of my students ask me if they could put this binomial in front of the trinomial, and you're welcome to do that. I don't. I just distribute from left to right. And so I'm going to take my 5k squared and multiply it by 4k and multiply it by positive 3. I'll do that first. 5k squared times 4k is 20k cubed. 5k squared times 3 is 15k squared. Now I'm going to distribute my negative 3k. Negative 3k times 4k and negative 3k times 3. So negative 3k times 4k is negative 12k squared. Oh, not a very good square. Negative 3k times 3 is positive 9k. And then I'm going to distribute my 2. Positive 2 times 4k, positive 2 times 3. So I'm going to do positive 2 times 4k, which would be 8k, and positive 2 times 3, which would be 6. And then what I like about this, when the binomial was last, if you look, I already have all my like terms together, and I have the largest exponent first. So I like having the binomial second, but it does not matter the order that you multiply. Remember, multiplication is commutative. So whatever the order is, it doesn't matter. You're going to get the same answer. 20k cubed, that one's gone. Here's my 2 like terms. 15k squared minus 12k squared is going to be positive 3k squared. Those are gone. 9k plus 8k is 17k plus 6. So there's my answer to question 2. Be careful when you do one like number 3 and number 4. Students just tend to say, okay, 36n squared plus 16. That's the answer. Remember, this means you're multiplying this twice. So you have negative 6n minus 4 times negative 6n minus 4. You will get a different answer besides 36n squared plus 16. Now, you actually will have 67% of the answer, but you won't have the whole answer. Now, I want to show you both ways to do this. You can draw the little rainbows like I do up here, and I will do that in just a second. Or you can say this term times this term. Negative 6n times negative 6n minus 4. And then this times this. Negative 4 times negative 6n minus 4. So you can do that either way. You can draw the little rainbows, or you can do like this and distribute. I want you to watch. We're going to get the same answer. I'm going to draw my little, what I call rainbows. Negative 6n times negative 6n, negative 6n times negative 4. Negative 6n times negative 6n is positive 36n squared. Negative 6n times negative 4 is positive 24n. Then I'm going to distribute, draw my little rainbows. This is distributing. Negative 4 times negative 6n and negative 4 times negative 4. So negative 4 times negative 6n is positive 24n. And then negative 4 times negative 4 is positive 16. Now I want you to look. If I distribute this to this, 36n squared plus 24n. If I distribute negative 4 to this, I get positive 24n, positive 16. So it is the same thing. I think this just makes it easier for some students to see, maybe more concrete, whereas just drawing these little arrows may not be as concrete enough for students. Okay, so I'm going to combine like terms. There's nothing to add to 36n squared. 24n plus 24n is 48n plus 16. Okay, let me do the next one. I'm going to skip this step here. If you like it to do it this way, this one on the bottom, then you may. I'm just going to draw my little arrows. I'm just going to distribute sort of in my head. I hope that's okay. But if you like the other way, please do draw that out. But don't forget to write this twice. Oops, I forgot that C. And then distribute. 4a times 4a, writing with my left hand, is 16a squared. 4a times negative 3c is negative 12ac. 3c, always put my variables in alphabetical order, by the way. Negative 3c times 4a would be negative 12ac. Negative 3c times negative 3c would be positive 9c squared. Add my like terms together, and in this case You want to put them in descending order based on one variable. So I'm going to just do it based on a. I'll just leave this c squared at the end. So 16a squared minus 24ac, combine my like terms, plus 9c squared. That's the answer to number 4. Okay, number 5, I don't have to write out 2 of them because I already have 2 there. I am going to distribute. Maybe I can do that with my left hand. Wasn't too bad. Negative 2x times negative 2x would be positive 4x squared. Negative 2x times k would be negative 2xk. Oh, I should say kx, shouldn't I? Negative 2kx, putting them in alphabetical order, really doesn't matter. And then negative k times negative 2x would be positive 2kx. And then negative k times positive k would be a negative k squared. Again, I have 2 variables, so I'm just going to put it in descending order based on this first one. So I'd have positive 4x squared, negative 2kx plus 2kx, that gives me 0, minus k squared. There's the answer to number 5. Typically, the answer to multiplying 2 binomials is a trinomial. Here's an exception to the rule. Notice, though, you've got a minus and a plus, and both of the terms are the same. So this is what happens when you have that instance, which might help you when you look at number 6. Okay, so here I've got 1/3 h times 1/3 h. 1/3 times 1/3 is 1/9 h squared. Remember, 1 times 1, 3 times 3. 1/3 h times negative 2/3 j would be negative 2/9 hj. Then 2/3 j times 1/3 h would be positive 2/9 hj. And then positive 2/3 times negative 2/3 would be negative 2 times 2 is 4, 3 times 3 is 9, 4/9 j squared. Now I need to combine like terms. Nothing to go with h squared. Negative 2/9 hj plus 2/9 hj. Those are the same thing. They would cancel out. They would give me 0 minus 4/9 j squared. And that's my answer to number 6. Hope that helps.